started with the first talk. So I am Shivji. In case you are wondering who is the one spamming your mailbox saying come to the meetup, that's me. I am a staff engineer at Nutanix. Why is this? Okay. And along with me, I have Dinesh, who is my colleague. And together we will talk on sort of how we've used Druid and how do we run it on Kubernetes, how do we migrate and stuff like that. A quick legal disclaimer that was basically saying that, whatever we present here are our own opinions and we don't represent Nutanix Corporation in the official capacity. So like I said, I am a regular software developer, mostly excited about distributed systems, and in particular databases, streaming, open source software, and lately I think I am starting to fall on talking too much in the community, this being one of those, right? And then I have Dinesh with me, who will introduce himself.
Hey, thanks you. So hello everyone. So Dinesh here. So I have around 14 years of experience, spent last 5 years with the Nutanix, and I have worked, played various roles in an SDLC cycle, currently playing as a DevOps engineer over here. Like earlier, Bharadwaj mentioned, like I really love infrastructure, cloud, and that's the thing that's the one of the reason that I am going to doing this presentation for the Druid on the Kubernetes.
Okay, thank you, Dinesh. Okay. Given this is the first talk, we will start with some basic analytics database information. Quick Druid primer. It's vast, so we can't go too deep or too broad, but we will give a very quick primer to take sort of other people along who don't really know Druid analytics databases so much. And then we will quickly move over to the components in the architecture that sort of build up the whole database. What we love about Druid, numbers from using it for over 3 years in production, very, very quick Kubernetes primer. And finally, how did we migrate to Kubernetes from wherever we were, which we will describe. And finally, the challenges and learnings. Okay. So a quick show of hands. How many of you have used analytics databases? Quite a few of them. Great. And how many of them have? How many of you have used Druid? Oh, quite a few. Amazing. Any other analytics databases that people have used? ClickHouse. How many of you? Pinot, Snowflake. Okay. Redshift. Okay. We have a lot of Druid users here. Great. Yeah. How many of you have used Kubernetes in production? Oh, again, quite a few. So we have a great audience here. It seems there's some delay with this. It's not working. Okay. Now it works. I think I was standing at the wrong place. So very quickly, these are some analytics databases that I have lifted. So I have posted here. Snowflake, Redshift, BigQuery. Those are your sort of closed source available as a database as a service offering. The bottom three, Druid, ClickHouse, Pinot. These are just the few that I follow. The bottom three are all open source. And they're also available to use with database as a service. Now, if you look at all of these columnar databases in this set, and I think this is something that you can extrapolate to other databases as well, is that they are columnar databases. How does that compare with row versus columnar storage? So if you've used a Postgres, MySQL or something like that, which is a row-based storage, you look at the top, there's a table with sort of country, product, and some sales numbers, and there are 4 rows there. In the row store, the picture on the bottom left, you see that you have the first row, all the columns of it represented together. Then the second row, which is India, ice cream, and 2,000 units sold or something like that. And then you have everything row-wise. On the other picture, on the column store, bottom right, you see that the brown box, all the columns for rows, the country column for rows 1 through 4, all of those are stored together. Then you have the blue one, product, all the products together, and then you have the sales numbers. Now, this is something that is common between all of these databases. And the reason is that the kind of queries or the kind of requirements that you will have from analytics databases, typically, column store is a great choice. One very quick example would be that, because all the values in one column are of the same data type, compression is something that you can do quite easily. It would work sort of in better compression ratio. And then there are other implications as well. Very quickly, a Druid 101 for people who sort of haven't used Druid or sort of forgotten a bit. It's open source, Apache 2 license, and under Apache Foundation, so you can sort of be assured that the source code is going to be there for you to use. Columnar storage, we've covered, tuned for high performance and supports real time as well as batch ingestion. Segment-oriented storage is something that we look for in most of the distributed systems we like to deploy in our production, and Druid is one of them. Basically, whatever data you ingest, ultimately that will end up being in the immutable segments, and these segments will be distributed over certain nodes, and those nodes will be the one from where most of the queries will be served, or some part of most of the queries will be served. Well, I'll come to the details in further slides. It's distributed. The modular architecture is actually quite amazing. In fact, the first time I read the Druid white paper, I think it stays in the face saying, wow, this is what modular architectures can do, and this is the advantage, stuff like that. So if there are younger engineers, I would really say that, you should read the Druid white paper. And I have referenced it at the end. And the last point there being data tiering. This is something that we absolutely love. It helps us keep cost under control by keeping cold data on sort of cheaper storage, as well as it gives us some kind of isolation and durability guarantees. So there is a lot that is good about Druid. What are some things that we absolutely love and for which we sort of stayed with Druid in our workload for this over 3 years? First of it, modularity gives us separation of concerns. This is something I think most of the engineers would love. Simplicity, because every component is only trying to do the one thing really, really well. So it's sort of, if you just upgrade or sort of, you want to migrate or whatever you do, you can only work with that component. There is only so much to do, debug and stuff. It's great for operational maintenance. It gives us the flexibility in the sense that we can only scale what we need, right? Imagine all of these functions were bundled together in one process which runs in one node, whether I have to sort of scale compute or storage or network and all, I'll probably have to sort of take the whole thing along. So here I get that flexibility. And then again, retentions, we sort of put there. That flexibility allows us to, retain data only for certain amounts of time in these tiers. It's built for cloud, I feel, because the components are very well defined on what they do, and which means they are defined on what resources do they need from the system. Accordingly, you can select nodes, you can scale things horizontally, most of them. And then the object storage that I talked about, in our case, we use S3, or when we deploy it in data center, we use Nutanix objects. For metadata, Druid provides an interface behind you, which you can put different SQL databases, whichever you like. In our case, we use Postgres there. And then finally, the admin dashboard is something we love because, it's not like for everything an SME has to be sort of asked for debugging and monitoring the system. We can have sort of a lot more people going to the Druid dashboard and checking their workloads and stuff like that. Finally, I think this audience has used Druid a lot. So I think this is more relevant for this audience. There's going to be a lot of content in this slide eventually, but the way I'll go is I'll sort of display module by module in this animation. I'll talk about every module as its responsibility. And then eventually we will look at the write path and read path guided by some arrows in the animation. So first up is historical. Historical is where your data, let's say queryable data stays. So when you ingest some data via some path that we will see, it will end up going to historicals, and the Druid segments containing this data, the immutable segments, they will be distributed mostly evenly around all these historical nodes. And when you query most of the data for the query, at least the historical data for the query, will come from these historical nodes. Then there is middle manager. Middle manager is another bunch of workers which is tasked with executing tasks for ingestion. And you can scale that horizontally like you see in the diagram. Coordinator coordinates between historicals, deciding, which segment should go where, how do I balance the stuff like that, how do I add a segment, drop a segment, things like that. Overlord manages sort of to distribute tasks between middle manager workers. And these middle manager workers basically have something called peons. So if the middle manager has, let's say, 10 tasks, it will sort of, for every task, it will try to spin up a JVM process. That JVM process will execute that ingestion task. In sort of, if you look at the latest Druid code base, called indexer, but I think it's still a little bit experimental. So we are really excited that, from process based, this is going to move to thread based task execution. So we are having a look at that, but that is something that is quite interesting. Then there are some external dependencies. You see Zookeeper. Then you see metadata storage, where we use Postgres in our case, but you can use other SQL databases. Then there is deep storage, where we use S3. You could use other object store or SDFS, and even Nutanix object store. Broker is where your external clients will end up asking to execute queries. You can put routers, and it's recommended if you have a production setup that is sort of supposed to take care of a lot of data ingestion and stuff. So router is basically optional, and it will help you route queries to the brokers, overlord, and coordinator. Okay, so we come to the sort of write and read path. First, with write path, you can sort of have streaming ingestion, or you can have batch ingestion. So the kind of workloads which we are talking about here, those clusters for us are using batch ingestion. And for the streaming ingestion, I think the third and fourth talk, they use streaming ingestion, so you'll get more insights there. But very quickly, if you look at the write path, you ask the router to route the writes. It will send it to overlord, which will take the ingestion task. It will ask middle manager to execute that task, and middle manager will eventually spin up a peon process, which will execute that task. And sort of the data will eventually be put by these peons on deep storage. And eventually, that new arrow is dotted because deep storage to historical will not sort of go directly. It will go via coordinator. But just to sort of keep the picture clear, I sort of put a dotted line, conditions apply and stuff like that. Very quickly, on the read path, you again ask the router to execute a query. It tells the broker to execute the query. If you don't have routers, this will go directly to the broker. Broker will talk to historicals. The name is so good, no? Historical data. Middle managers have some of the latest real-time data, which are not there on historical yet. This will eventually land up there. So broker will get data from middle manager as well as historical, sort of combine them up and serve what you expected from the query. Some numbers from our production. This is one of the clusters. We have 3 clusters running today. The cluster size is 18.5 TB of data ingested there, 294 data sources. And if you look at the last 24 hours, I'm not sure you can read the text over the numbers because that's coming from the Grafana dashboard screenshot. But what it says is we have seen 423K tasks being ingested in the last 24 hours and around 8 million queries fired on this cluster. Again, proof of the pudding. Grafana dashboards. We have around, in the peak, we have around 380 queries per hour. And on the ingestion side, the graph at the bottom, you see that you have close to 19K on the peak of ingestion in terms of the tasks. So now we talked about Kubernetes, but where did we come to Kubernetes from? We were earlier using the HashiCorp stack, which means it was backed by Nomad on and Consul, deployed on AWS. Our metadata storage, Postgres RDS, and deep storage S3 bucket, I have mentioned that. Nutanix. So why did we actually move to Kubernetes from HashiCorp stack, right? At the time we decided to do that, Nutanix Kubernetes engine is one product that is there internally. So we are already providing that in the data centers for Kubernetes as a service for people that use Nutanix infrastructure. It's similar to something like EKS in AWS cloud. And then there were a lot of teams internally that were already using Kubernetes. So it kind of makes sense that in the same org you use the same tech and reduce the sprawl. So that was sort of the main motivator. And then we started looking at HashiCorp versus Kubernetes. I think there's one line missing there somehow. What I say there is, one of the great things about Kubernetes is that you can be on data center. For instance, it will be backed by Nutanix and you have Nutanix Kubernetes engine. AWS cloud, you have EKS. Likewise on GCS, Azure, wherever you go, you basically will have the Kubernetes pane. So you can take your Druid or other data platforms or even microservices in a lift and shift fashion. I mean, I understand it's not so easy, just migrating stuff, but that's what we try to do at Nutanix. So basically our whole data platform stack becomes sort of portable across clouds and even to data center. Now that all these infrastructure providers or cloud providers provide Kubernetes, obviously there will be a lot of adoption, and a lot of adoption means better ecosystem. There is already a good ecosystem, and we were like, if somebody today comes up with the infrastructure piece, it will end up being sort of integrated with Kubernetes. Case in point being, Druid already has Helm charts and operators. These are sort of your files that allow you to run things on Kubernetes. Kubernetes is obviously Apache 2 license and CNCF graduated project. For anybody who is following HashiCorp, they would know of the recent license changes and stuff. There's a lot of talk in the community around that. Kubernetes used to have has had stateful sets. Helm and operator, like Dinesh will explain, end up using those. These stateful sets were not there in the HashiCorp stack. Now I think it's there, but still in the beta phase. And well, I mean, for the Kubernetes, we are sort of an ever expanding team, and we think for Kubernetes, we will find it easier to hire and expand the team. And finally, the current deployment, if you look at it, we don't use, so this Druid cluster is deployed on AWS, but we don't use EKS. We are actually quite scared of being logged into one vendor. We always want to keep everything vendor sort of login free. So on AWS machines, we use something called COPS. It's like Kubernetes operations. It's a open source thing on GitHub. We use that to put a Kubernetes pane on top of these EC2 machines. Then we use the Druid Helm charts, and we use sort of in the Helm charts repo, we use GitOps deployment model sort of to make changes in Helm charts and stuff. And Argo CD is something that helps us sort of put that into effect. I'll hand over to Dinesh at this point. He's the one who's worked a lot on moving this to Kubernetes. So Dinesh, yeah, please.
Hey, thank you, Shiv.
You can come here, Dinesh. Come back and point this side.
Okay.
It's a bit weird, yeah. Is it working? I can move it for you if you want. I've learned it somehow. Okay, I'm sorry. So can we move the slides from there? Okay, fine.
Yeah. Okay. So before we go, like how we deployed a Druid on Kubernetes. Now, these are some of the important actors in that movies. I would like to just give the introduction about these actors, right? The first is the stateful set. The stateful set, I think some of the folks who are already have some information about the Kubernetes, they know the deployments, right? Now the basic difference between the deployments and the stateful sets, the stateful set always have the persistent storage, and it has a unique identifier attached to it. Okay, so now another component is a daemon set. Now what happens when you deploy a pod, right? So when you deploy a pod, the pod gets scheduled and the pod will find a node to get deployed on. However, in the daemon set, it is exactly the opposite, right? So once you add a node to your node group, automatically the pod will get deployed on that particular node. So that's the daemon set. Another is a persistent volume claim. I won't go much deeper into this. A very layman example can be a Docker volume, any NFS volume it will be. Config map. Now the config map, it's a Kubernetes object where you can store the various kind of configuration either in the key value pair or in the file also. So one of the best example, you can store a zookeeper configuration, zoo.cfg. If like anyone has seen, you can store into config map and then use it for the zookeeper deployment. Init container. Now this might be a new concept from some of the folks. Now what happens when we deploy a pod? Inside a pod, you will always get an application container get deployed using the image. Now what if that particular container has some prerequisite that some of the service should be up before that application will get up, or some configuration should be already present, right? So now this kind of use case you can solve using the init container. So whenever there is a init container configuration present in your deployment YAML, the flow will be like, it will the first init container which will come up, it will do the pre-checks, it will check it out. Once the check is completed, init container will go out of a picture and the main container will come into the picture. Okay, now the secrets again, it's a Kubernetes object to store your all secured information. It can be your SSL certificates, it can be your key, your username and passwords. So these are some of the components. Now, yeah, okay. So now here we will see how, like Shiv has explained, all the Druid components, various component Druid architecture, and how we have mapped that components with the Kubernetes. So now these Druid components, we have actually divided into the three sets. The first is the stateless components, another are the stateful components, and third is the external dependencies in the Druid world. The first set, the router, broker, coordinator, and the overlord are the stateless component. So we get deployed using, we are deploying as a deployment over there. So because we just need that components to be up and running to manage the Kubernetes Druid workflow. Now the middle manager are the historicals. These are the two components where you require actually persistent storage. So here we are middle manager. For our use case, we are using a daemon set with a persistent storage attached to it, right? And historicals, we are using the proper stateful set with a persistent storage attached to it. Now again, like Shiv has already mentioned, this Druid on Kubernetes, again, present on AWS. So for the external dependencies, the deep storage, we are using the RDS only for the, S3 bucket, and metadata storage, we are using the RDS. The last and the most important part of this entire zookeeper who makes this entire component communication enable is a zookeeper. Zookeeper, we have deployed it again as a stateful set. Like I said, it's the most important component. It stores the configuration, it stores the metadata information, and it enables the entire Druid communication possible. So we have to make sure that this particular zookeeper should be in a stateful set only. Okay. So now this is how when we deployed a Kubernetes on a Druid, we deployed a Druid on a Kubernetes looks like. You can see the users are able to connect using to the Druid using a well-defined endpoint defined in a route 53, which is pointing to your ALB, and ALB is connected to only one entry, that is a router service. Now, like I mentioned in earlier slides, your router, broker, and the coordinator and overlord, these are deployed as the deployments, right? The middle manager, historicals, being a stateful components, has a PVC attached to it. Another important component on the on that side, you can see a zookeeper. So zookeeper, like I said, it's an important component. We have deployed a 3-node zookeeper. It maintains a quorum, and we have deployed it as a stateful set. Now this entire structure is deployed. All the components are deployed into the single namespace called as the Druid. In the bottom, you can see your external dependencies again, deep storage and the RDS. Okay. So now after this slide, we are going to see how we migrate. Like on earlier, we have deployed a Druid on a Nomad, right? Now we have deployed a Druid on the Kubernetes. Now we need to make this migration. The application need to be migrated from the Druid which you are using on a Nomad to the Druid on the Kubernetes. Okay, so now let's consider this is your D-Day, right? And your entire migration process start. Now this migration process will have the 3 important phases. The first phase is a preparation phase. In the preparation phase, we already seen our existing structure, Druid on the Nomad with external dependencies, right? And the users are using this one. The second, now this is a new deployment which we have done, Druid on the Kubernetes. Now the one important factor over here, you can see the Druid which is deployed on a Kubernetes are connected to the temporary newer instance of S3 bucket and RDS along with the zookeeper. Okay, so now why this is required? Now since this is a preparation phase, we will require this thing to verify the functionality of Druid on the day of migration. Using this entire component, now you can verify that your Druid is entirely working for every read, write, and query path. Right? Now the second phase. Now your preparation phase is done. Right? Now the second phase is your data sync phase. Okay. So till now, right? So till now, the application, the users are still pointing to your Druid on Nomad. Okay. Now what will happen in a data sync phase? We will stop the overload and the middle manager. Like Shiv has earlier mentioned, the data ingestion, the most important responsible components for both are overload and the middle managers. So we will stop the overload and the middle manager on the Kubernetes side. Okay. Then we will disconnect the metadata storage and the deep storage from your temporary components, and we will connect to your S3 bucket and the metadata storage of a Nomad. Okay, so now why we stopped the overload and the middle manager on the Druid side? Because we want to make sure that the data corruption should not happen. Because now we are pointing on the same S3 bucket and the metadata storage, right? So now once these are connected, now what will happen? So once you are connected, the Druid historicals which are present on the Druid which is deployed on Kubernetes, it will start downloading the segments, right? It will start pulling the segment. Why it will happen? Now the reason behind that is the most important component is the coordinator in a Druid. The coordinator is responsible for the availability of data, replication of data, balancing of data, right? So once you connected this particular Druid on Kubernetes the coordinator will go and check the segment table into the metadata storage and check the segments, right? And it will write that particular segment information into your ZK path. Now with ZK path, it will write that ZK into the newer ZK which is deployed on the Kubernetes. Okay. Now the segment information is written on the zookeeper. It is written on the path called as load queue path. Now what will happen? The historical will now check the zookeeper over there. It will see, okay, I have to check whether this segment is present into my segment cache or not. If it will find, okay, it is not present, and it will start downloading the information from the metadata storage, S3 bucket. And this now, again, I'm mentioning one more time, till this phase, the read and write still are going on a Nomad Druid. Data corruption won't happen because the source of truth is a single point, right? Only why we have this data sync phase. Now let's consider you have 100 TB of data and you require enough time to get that particular data loaded on the historicals. Now in a data sync phase, you can take enough of time, like depending on the speed, latency, whatever may be the reason, and you can make sure now that whenever the entire data are loaded on the both side, now you are ready for the next phase. The next phase is your cutover phase, right? So now this is a cutover. Now this is a phase where you are actually going to change your endpoint. You are going to ask the users, okay, now you are done with the older Druid on Nomad. What we did, we stopped the before we point your application users to the Druid on KTS. Remember, we have downscale the overload and mineral managers to 0. Now we will upscale that particular thing, and now we will point your application users to this thing. Now this can be done in a very simple thing. It can be your route 53 ending pointing to your new ALB address. That's a very simpler part. Okay, so now once this is done, now your particular Druid on Kubernetes is ready. Again, one time mentioning, there won't be any data corruption till this moment, because the source of truth for the data and the metadata are the same. Right? Okay, so now this becomes your D-Day. The first day you are done with the deployment, right? You are done with the migration process. Now what happens on the day 1 and plus? Now there comes the picture of the upgrades, right? Then we require the reliability. We have already deployed Druid, right, on the Kubernetes. Now these are some of the factors we have to make sure so that we will have the zero downtime, we will have the proper compliances and everything. Now the upgrade part, the most important part with the upgrade. Now the upgrades are always in case of when you deploy any application on a Kubernetes, it is always there will be two types of upgrades. One is the application upgrade, and then is the infrastructure upgrade. The application upgrades consist of you are upgrading a Druid version, you are updating a configuration of a Druid. Infrastructure upgrade, you are updating the Kubernetes version itself. You are updating the EC2 node on which the Kubernetes components are deployed due to some kernel upgrade mentioned by the AWS. And these are the scenario whenever you can't say no, right? You have to go. So now when you are doing these two upgrades, we want to make a reliability that whenever these upgrades are happen, still your Druid is into picture. It is able to read the data. It will able to write the data. Now for that reason, to maintain this reliability, what we did, we had minimum of 2 replicas of each component, right? Though coordinator and overload, we know they can't horizontal scale. The reason we use coordinator and overload with the 2 replicas, if there is an application upgrade, one coordinator goes down, still one broker goes down, one overload goes down, still another overload will be able to pick that task, or broker will pick that query and it will able to serve that query. Okay, another part is the spread across the AZs. Since we deployed, like I said, in the production, this is always a picture. You want to have a replication across the availability zone. So you can spread your pods across the availability zone using the 10-cent tolerations, right? Another thing which you can use during this upgrades to make it more reliable is a PDB, the pod disruption budget, right? What the pod disruption budget helps you, it always makes sure that if you have 3 replicas of any component, and if you have configured a PDB as 1, it will always make sure that only the 1 replica of that component is unavailable. It won't make till that time that node won't be go for the upgrade. And this is the PDB is most important required whenever you're doing an infrastructure upgrade, because most of the time you don't want to sit with the infrastructure team. Being a Druid application team, you don't want to sit with the infrastructure team during their upgrades. And if we have keep all these things into picture, we don't have to worry about them, because we have already configured in that way that only one pod will go down and rest of the pod will always remain up. Right? Now, the another part is the scalability. The scalability, here we have used like a two things, right? The first part is a horizontal pod scaler. I think the folks who have worked on the Druid in the production must have known about this. The horizontal pod scaler, you can scale the pods using some metrics, either the predefined CPU kind of metrics or the custom metrics, which you can get it from Prometheus or anywhere. Now, the horizontal pod scaler will always work with another component called as a cluster autoscaler. Because the horizontal pod scaler, it's as the name said, it will only scale the pod, right? Now, let's consider a picture. The broker, it sends some more queries than came, and it need to scale the pods by 2, right? It will increase the pod by 2. But what if there is no nodes available to use that particular brokers, right? So there actually the cluster autoscaler comes into picture. It will sense, it will see that some of the pods are in pending state because the nodes are not available, so that the cluster autoscaler will spin up one of the node, it will add into ASG group, and your pod will be up.
Time check.
Right? Another part is an auto-scaling group with the daemon set. Now, this is a particular use case we have used, right? So, why, and this particular use case we have did with your middle managers. Now, why we did this? Because this gives the power to the application team to auto-scale as their requirement. So now what happens? Let's say the application team suddenly sends a burst of load, ingestion task, right? Like a middle manager, it's an ingestion always. And we can see there is not enough middle managers to take the task. So now they can see around, they can check whether your enough middle managers are there or not. If the middle managers are not enough, what they will do? They will just go and scale the number of nodes entire auto scaling group, right? So they have to just interact with the auto scaling group. So once they go and mentioned, okay, increase the 5 nodes. Now, since it's like I said, we have deployed a middle manager as a daemon set. That is the reason we did that. Now hello, yeah. So now, since they have increased with the middle auto scaling group, my middle managers already get scaled up. The last part, which is required for the compliance and security, image scanning. For our scale, for our use case, we are using the ECR as our image storage. We are using the ECR image scanning facilities, right? We have actually successfully scanned images which have shown the vulnerabilities during the Log4j issues. We have fixed it, pushed it. Another part is your secret management store. Okay, so that's it for entire like a Druid on migration. I will hand over to Shiv for the next part.
Sure. Thanks, Dinesh. So we already have a time check warning, so I'll go through this a little bit quicker and save some time for Q&A. So these are some challenges and the learnings we've had over last 3 years of running Druid in production. So when I sort of introduced Druid as Druid 101, I said it's the components in the architecture that you saw are horizontally scalable for most parts. Well, the catch is there are a couple of them which we have had to scale vertically. In our case, probably also because we use Postgres. But in the next talk, Kashif will just talk about how to sort of do better there so that this doesn't become a bottleneck. In sort of one of the recent re-architecture, we had this issue here, and because of time constraints, I'll skip those. But I'm myself looking forward to listening to Kashif on how he recommends to sort of take care of these and what are the latest changes there. You should also, I think, in my opinion, keep track of the size of task spec payloads. In our case, we were ingesting sort of data for 3 hours together, sort of once in 3 hours, and we collect everything in between in the application DB. And then we sort of hit this limit in Znode sizes. Number of segments, that is something that you should keep track of. Files in task spec, in sort of one of the cases, we put prefix based paths. So Druid went up opening all of that, and that was like too many files for Unix defaults to be happy with us. So you will have to either sort of take a track of it or change Unix or Linux defaults. The other issue we have had is when we have upgraded the last couple of times, and one of those were like version 19 to 23. So like us to blame as well. Like we didn't upgrade for so long and suddenly upgrade across versions. So the issue we have had is that, you know, we have a UI where basically the sort of customers make their choice, so the user makes its choices, and the query for Druid is auto-generated. There we sort of sometimes end up generating something that is pretty corner case, and in those cases, Calcite sort of planner crashes. So we typically sort of put this version upgrade like you would do every time on staging cluster first, and then see if there is any crash or something. Then when we move it to prod, it's sort of pretty seamless. But then those issues are something that we have faced a couple of times. We have reached out to community. They've been very helpful. And then we've managed to sort of fix those quickly or find a workaround very quickly. And like I said, for the Calcite issue, I would upgrade. I think that's not specific for Druid, but any distributed system, I would say, you know, or anything actually, upgrade one version at a time. That keeps you safer. Too many components is something I have been saying that it's amazing, but then there is no free lunch. Obviously, a lot more components means a lot more maintenance, a little bit of a steep learning curve. And in my own opinion, I think for a tiny workload where you don't need economies of scale, I think Druid has probably too many components to work for a smaller scale. We like to separate ingestion tiers so that, you know, let's say there's a compaction tier, there is a sort of ingestion tier, so they didn't sort of conflict with each other for resources. And we had this case where our partition spec was set to dynamic, and sort of the subtask there, we couldn't differentiate between which one is coming from the compaction and which one from our own ingester tasks. Lastly, around Kubernetes, we don't really have time to discuss a lot, but I think around Kubernetes stateful sets, and sort of in our case, the kops library that we use for making up the Kubernetes pane, when we upgraded those, we had a lot of issues. That was also because kops ends up sort of upgrading Kubernetes version out of place. So you have new nodes where everything goes. And the stateful sets, we've had to play a lot, learn a lot of things to get it working smoothly. Like I said, Druid white paper is amazing. I used to actually think that, you know, for open source sort of data systems and stuff, because the docs are written by backend engineers, they'll generally not be so amazing. Druids prove me wrong. The Druid proves me wrong there very clearly. The documentation is actually quite amazing. Helm charts and operators, these are stuff that help you deploy Druid on Kubernetes. They are also available open source, and these are sort of good how-tos on Kubernetes. There are also a couple of blogs which we'll update later. I think we forgot to update those. And finally, I think we have two folks on our team sitting here, Sachin and Bhardwaj. These were the guys who actually worked on all of Druid, running it for 3 years. I don't get all the credit for that. So if there are any question answers, you can ask me, or if you don't know some stuff, we'll take, so they can also take those, and there are other PMC folks and stuff. So yeah, let's get to Q&A very quickly before we start. If there are more questions, there's the Druid community Slack, which is very useful for us. And then you have speaker contacts. So yeah, we are open for Q&A. Can we take a couple of questions?
Yeah, I think in the interest of time, we can take the 1 or 2 questions. For questions that are online, the speakers will directly reply to you. But yeah, if anyone has maybe 1 or 2, yeah, please, the gentleman. Could you please pass the mic? Meenakshi, can you pass the mic, please?
Dinesh, can you come up?
So I had a question regarding the kill task, basically, on open source Druid. So if we do not disable it and let it running on its own, so basically the number of tasks that get spawned are equal to the number of ingestion tasks that is running. So running within a second, all tasks gets executed, and because of which a CPU spike can happen. So how do you
Could you keep the mic closer, please?
So how do you manage in a kind of batches, or like how you're trying to address that issue? Kill task is basically to get rid of the old segments.
Did you get the question?
I'm
No.
sorry, I did not
Can you
get the question.
keep the mic closer and repeat the question quickly again?
Okay. Are you aware the kill task on Druid? Yeah.
Kill
so
task, yeah.
how are we managing that kill task over here? Are we doing it with batches or all at once?
So the way this works is every few hours we set up the kill task saying that you can only kill so many segments. So we also know the size of segments and number of segments. It's very predictable. So we don't have an issue. And even if there is an issue, we can run it separately on a different tier of nodes so that you can kill it independently. Does that answer your question?
That I guess we are trying to use an airflow mechanism or somehow to schedule these jobs. So there is no configuration.
Okay, maybe this is something we can take up maybe in the offline section. The speakers will be off stage. We can even connect in the networking session if that's okay.
Yeah, thank you.
One more question.
Yeah.
Hi. So you mentioned that you are running everything in Kubernetes and you are managing your own Kubernetes cluster.
Yes.
Talking about cloud, any cloud provider, let it be AWS, GCP, Azure, they all charge $73 per month for managing your master node. With introducing the complexity of managing your own Kubernetes cluster images, what was the challenge that you faced there that you moved to managing your own Kubernetes cluster on top of AWS? And what was the benefits that you got from that?
Yeah, can you pass the mic, please?
Yeah. So the first thing why we used, so once actually you used any vendor managed Kubernetes thing, right? You are actually get locked into that part, right? So though it's a master, I know that you, if you want to move to Azure, you have a AKS, you have a GKE, again, it's a managed by us, right? But however, there are some of the places where you want some kind of granular control on the master side, which the cloud never provides you. They won't allow you to do like, again, on top of that, if you have seen the EKS, right? Every 3 months, they will make one Kubernetes version that we are not going to support it, right? So you have to follow their norms also. So that is the one thing we don't want to get locked into, and we get a more granular control to all the upgrades and some of the parts like Shiv has mentioned, we are using the COPS. COPS gives you a very, very good control over the upgrades and everything, which we don't find in the EKS or the cloud managed Kubernetes. That's the only reason. I don't think so, because again, one thing only cloud will provide you is that your control plane is since managed by them, they will make sure it is uptime will be always there, right? Apart from that, again, from the node group side, it's again on your control, right? If you want to upgrade EKS also, only the one-click upgrade happens on the control plane. Node group upgrade, you have to do it on your way, right? So from the performance point of view, I don't like think we haven't seen that kind of thing. And again, to just reiterate, it's a granular control which we get, right? Yeah.
To add to that, actually, what COPS gives us is the assurance that, I go to, let's say, data center, I don't have the same Kubernetes, but for me, this is the pane that just carries over to another cloud. So I just use some VM nodes on data center, different clouds, whatever, right? So we are sort of very high on control and the flexibility it can give us and portability, like I said, right? Yeah.